We're going to learn how to write an empirical formula, which is the simplest whole number ratio of elements in a compound from the percent composition of a particular substance. So to get started, I'm going to provide us with the following flowchart, which will give us the ability to take the percent composition of a substance and work our way over to what that simplest whole number ratio is going to be, which is ultimately called our empirical formula. The percentages that we're going to start off with to be able to write an empirical formula are given in front of us. We have 82.4% nitrogen and 17.6% hydrogen. Now the first thing we're going to have to do is change these percentages to grams. And to do so, we need to assume a sample size. The easiest sample size to assume is a 100 gram sample. So in step one, we're going to assume 100 grams, and that's going to allow us to change our percentages to grams very easily. If you assume that 100 gram sample, whatever the percentages are, that becomes your mass in grams. So 82.4% nitrogen is 82.4 grams of nitrogen. And 17.6% hydrogen will be 17.6 grams of hydrogen. So we assume that 100 gram sample, so we could simply take our percentages and express them as grams. So that's step one. Now let's move on to step two. In step two, we want to now take the mass of nitrogen and mass of hydrogen, and we want to change it to a new unit. We want to change it to a unit that we can compare very easily in chemistry, and that happens to be a unit of a mole. So if we're going to be able to change grams to moles in step two, we're going to need to use our periodic table. We're going to need to use the atomic mass of nitrogen, which is the 14, and the atomic mass of hydrogen, which is 1. So if we take the grams that are provided and simply divide by those atomic masses, we're going to be able to change our units from grams to moles. So if we take the 82.4 and divide by the 14, hopefully you notice that the gram unit is going to cancel, leaving us with units of moles, and the same thing for the hydrogen. We're going to take that 17.6 and divide it by its atomic mass, which happens to be 1. Once again, the unit that's going to be canceling here is going to be the unit of a gram. And we can visualize that the grams cancel, leaving us with the unit of a mole. Now that we have units of moles, we have now completed step two, and we're ready to finish this process by simply doing a mole ratio. So let's go ahead and get our moles. Dividing the 82.4 by the 14 gives us the mole of nitrogen, that's the 5.88. And for the hydrogen, when you divide by 1, then you're going to get the 17.6 moles of hydrogen. So that is the end of step two. We now have our moles, and now we are ready to do our mole ratio. So in step three, we're going to ask a simple question. Which mole value is the smallest? In this case, that is going to be the nitrogen. 5.88 is smaller than the 17.6. So I'm going to divide both of them by the 5.88. And when doing so, we're hoping to get a ratio, and we're hoping that it will be the simplest whole number ratio of elements within this compound. So let's divide both of these by 5.88. And upon doing so, we get a ratio of 1 to 3. So our final formula here is going to be ammonia. It's depicted down below with the ball and stick model. And this allows us to write the simplest whole number ratio based on the percentages that we started with.